Okay guys, so let's take a look at the notes. So today we're going to be putting all of this together. We're going to be finding the asymptotes, intercepts, extrema, concavity, and the limits as x approaches infinity. If we get to a point and you feel like you understand it, feel free to work on the worksheet. If not, then you can follow along all the way through. So in example 1, we are given the original function. We're given the first derivative and the second derivative. We'll start off by finding our vertical asymptotes. That's whatever makes this original function undefined. What is that going to be? What is the value of x that makes the original function undefined? Jared? Yep. So we're going to have a vertical asymptote at 3 and -3. The next thing we're going to find is the horizontal asymptote. To find that, we can find the limit as x goes to infinity of our original function. So that horizontal asymptote, I'm going to find the limit as x goes to infinity of this. Well, if I plug in infinity, I'm going to get infinity over infinity, which is indeterminate. So I'm going to use L'Hopital's. Derivative of the top is 2x. Derivative of the bottom is 2x. I can now simplify this, and what do I get? 1. So my horizontal asymptote then is y equals 1. We're going to graph over here, so I might as well put in what I've got so far. So I have my vertical asymptote. I have 2 of them. I have my horizontal asymptote. Some other things we're supposed to find are the intercepts. If I want to find my x-intercept, I have to set this function equal to 0. That's the same thing as just setting the numerator equal to 0. So if I set the numerator equal to 0, I just get 0. So when y is 0, x is 0. If I plug in 0 for x, that tells me the y-intercept. I'm going to get the same thing, 0, 0. So that's the only intercept I have. In fact, I'll take off x and I'll just call it an intercept because it's really an x and y intercept. So I might as well go ahead and put that point on my graph. So now I've been given the first derivative. I can find my critical number. That's whatever makes that first derivative equal 0. So that means the top equals 0. So what's the critical number? 0. So I have a critical number of x equals 0. My possible points of inflection are going to be whatever makes the second derivative equal 0. So I would set this top part equal to 0. I divide by 54. I take the 3 over. Can I ever have an x getting squared and get a negative answer? No. So there are no possible points of inflection. So we have a critical number, we have no possible points of inflection, and we have vertical asymptotes. Those are the values that are going to be used to form the chart. Vertical asymptotes, critical numbers, and possible points of inflection, if we had them, would go into the chart. So what's our first interval going to be? Negative infinity to -3. Then we would use -3. Then what? Right? And then 0. And then 0 to 3. And then 3. And then 3 to infinity. Now, when we're testing our intervals, there's no need to find f of x when we're doing an interval. So just get rid of those. So I'm going to choose a test value, maybe -4, and I'm going to plug it into my first derivative. I should look at my first derivative. If the denominator is getting squared, will it always be positive or negative? Positive. So I know it's always positive here. So if I plug -4 in, I have a negative times a negative. That's a positive on my first derivative. If I plug -4 into my second derivative, in this one, the numerator is always going to be positive, no matter what x value I use. -4 squared is 16 minus 9. That's going to be positive. A positive cubed is going to be a positive, so that's positive. So what does my first derivative tell me? Increasing or decreasing, so we're going to be increasing, and we're going to be what? Concave up. So now I'm going to look at my boundaries. The asymptotes serve as boundaries. We can cross a horizontal asymptote, but we usually don't, okay? We will never cross a vertical asymptote. So in this region, from x being negative infinity to negative 3, I have to be increasing and concave up. Is that best represented by A or B? A. So it's going to have to look like this in that part right there. So now I'm going to go on to my negative 3. Negative 3, if I plug it into the original, it's going to be undefined. It's also undefined on the first derivative and on the second derivative. It's undefined in all of those places. What does that mean? We've said before that if it's undefined on the first derivative, it should be a critical number. But what's going to win out over that? Vertical asymptote. See, I want you to be able to recognize just by seeing the chart, without seeing any of that up there, that if you saw undefined straight across, it has to be a vertical asymptote. If you only saw it on the first derivative, it might be a sharp turn. Okay, so now let's go here. Negative 1. Plugging that into our first derivative. A negative times a negative is a positive. Plugging it in here, negative 1. The top's always positive. Negative 1 squared is 1 minus 9 is negative. A negative times negative times negative is a negative. So now we have to be increasing and concave down. I'm going to wait a minute to do this region because this region really goes from negative 3 to 3. 0 was what we were testing to see if it's a max or a min. If I plug 0 back into my original, I get 0, 0. I don't need to plug it in anywhere else, just here. I'm going to come down to this part, 1. Plugging 1 into my first derivative is negative. Plugging 1 into my second derivative, I'm going to get 1 squared is 1 minus 9, that's a negative again, so it's negative. So now we're decreasing and we're concave down. Remember that 0 was a critical number. If our function is going from increase to decrease, what's it going to have to be at 0, 0? Max, isn't it? So this is going to have to be a max. And so now we're going to graph. We're trying to go from increase to decrease and always be concave down. There would actually be 4 choices here, guys. It can cross in the middle. It can cross the horizontal asymptote. Is this part of the graph going to look like A, B, C, or D? C, yeah. You have to be increasing concave down, decreasing concave down. Has to look like that. And then when we test 3, we know that it was undefined already, and we already know it was a vertical asymptote. We don't need to waste time on that again. If I test 4, into my first derivative, it's going to be negative. Into my second derivative, all I care about is the bottom here. 4 squared is 16, that's positive. So we're going to be decreasing and concave up. So think about how that's going to look. Is that going to be A or B? A or B? A. Decreasing and concave up has to look like that. Okay? So that's what you're going to be doing. On your worksheet, I gave you the charts. You may or may not need to use all the lines. Okay, I'm going to go ahead and do this one and show you how to do it when we don't have a chart. Okay, how do we figure out how big the chart needs to be? So I'm going to start off by finding my vertical asymptote. Whatever makes this undefined, x equals 0. I'm going to find my horizontal asymptote. I find the limit as x goes to infinity. The limit as x goes to infinity would result in negative 2 minus 5 over infinity squared. What's a constant over infinity squared? So I have negative 2 minus 0. So my horizontal asymptote is y equals -2. I can start graphing a little bit. Here's my vertical. Here's my horizontal. I'm going to see if I have any intercepts. Bless you. To find my x-intercept, I'm going to set y equal to 0. So if I bring this over, I'm going to have 5 over x squared has to equal -2. If I cross multiply, -2x squared has to equal 5. X squared would have to be a negative. Is it possible to have x squared be a negative? No. So there's no x-intercept. To find the y-intercept, I plug in 0 for x. If I do that, it's undefined. So there's no y-intercept. So this one has no intercepts. All right, extrema, I'm going to have to find my first derivative. I'm going to think of this as -2 minus 5x to the -2. The derivative of a constant 0, -5 times -2 is 10x to the -3. There's my first derivative. Critical numbers, whatever makes this equal 0. Well, this is never going to equal 0. It's undefined at 0, but it's already a vertical asymptote, so I have no critical numbers. I'm going to go ahead and take the second derivative. 10 times -3 is -30, x subtract 1. Possible points of inflection are whatever makes this 0 and whatever makes this undefined. This will never equal 0 on the top. It'll equal 0 on the bottom if x is 0, but x is 0 is already a vertical asymptote. So all we have to go on this is the fact that we have a vertical asymptote. When I make my chart then, all I'm going to have is -infinity to my vertical asymptote, and 0 to infinity. I'll check f, f prime, f double prime, and then I'll think about what does that mean. So in this interval, I'm going to plug in -1 into not into my original, I don't care about that, into my first derivative. A negative to the third is a negative, so I'm going to have a negative. Plugging -1 into my second derivative, if I raise it to the fourth, it's positive, so a negative over a positive is a negative. So what are we going to be, guys? Decreasing and concave down. Here are my boundaries. Here's my asymptote, and here's another asymptote. If I want to be decreasing and concave down, am I A or B? B. Plus, I know it has to be B because I don't have any x-intercepts. See, I would have x-intercepts if it was up here. At 0, this was undefined, so we knew it was a vertical asymptote already. So we're just going to check 1. Don't need to check it there. Into our first derivative, positive. Into our second derivative, negative. So now what do we have to be? Increasing and concave down, right? So is that going to be A or B? B. And so that's how we use calculus to curve sketch. We can get much more accurate curves by using calculus than we can by just using other pre-calculus methods. Okay, any questions? All right, so you have your worksheet. You've still got about 20 minutes. I want you to go ahead and get started. If you need help, I'm happy to help you.